So in this lesson here, we're going to be taking a look at how do we solve for the square roots of decimals. Now remember, decimals are what we consider rational numbers, okay? Anything that, or the decimals that we're going to deal with are rational numbers, so these are going to be ones that have an end or a repeat, and particularly these ones are going to have an end. When we look at fractions, they might be ones that have more repeating on there, but we're going to look at solving square roots of decimals. Now as a little bit of a reminder here, perfect squares are natural numbers. Okay, remember, so no negatives, no decimals, that give us a natural number answer when taking the square root. Okay, so they are a natural number which gives us a natural number answer when we take the square root. Now, using the perfect squares that are known, the square root of a decimal can be found as well. Okay, one in particular, or the particular ones are ones that resemble our perfect squares. So we're going to be looking for ones that resemble our perfect squares. Okay, and that's going to be the important part. So something like this here, we have the square root of 0.25. Now you'll notice if we see the number 25 in here, okay, 25 should look familiar as it's one of our perfect squares. 25 is 5 squared. Now this is 0.25, so there's a couple more restrictions in place when we look at, is this one what we're going to call, quote unquote, nice number? Okay, is this a nice number which we can take a square root of and get a nice value back? Now a nice one means that it's ending or repeating decimal. Okay, so a rational number. We don't want it to be a non-ending, non-repeating decimal, or what's called an irrational number. So I'm going to use the term nice or nicely. We can think of it as a rational number as well. So when we are solving the square root of a decimal, the first thing we want to do is we want to check to see if there is a number that resembles a perfect square. And in this case, there sure is. We have the number 25, okay, which equals to 5 squared. Okay, so it is a perfect square. A perfect square, the number 25 is. Okay. Now, if the decimal value does not represent a perfect square, then the square root of the decimal will not be a nice, and again, I put that into quotations. We think of that as a rational number as well. Okay. In fact, it will be a never-ending, never-repeating decimal, okay, otherwise known as an irrational number. I'm just going to squeak it in there, okay? So it's also known as an irrational number. It's a never-ending, never-repeating decimal. It's an irrational number. Now there's a lot of those, okay? There's a lot more irrational values in square roots than there is rational ones. Well, we're just going to take a look at the rational ones for this course or for this these lessons here. Okay. Now, so first thing we do is we check to see is there a perfect square in there? So 25 is a perfect square, so there is a chance that it's going to be a nice number. Now the next thing we need to think about is perfect squares. 110,000 are perfect squares. Therefore, our decimal, okay, will need to end either in the hundredths, okay, so that's 2 decimal places, or the 10,000ths, okay, which is 4 decimal places. Okay, so it's going to have to either end with 2 decimal places or 4 decimal places and have a perfect square value in there. Okay, so these are kind of our 2 conditions that we have to look at. Okay. Does it end in 2 decimal places or 4 decimal places, and does it have a perfect square in that number there? Okay, so it's not a perfect square, as it's not going to give us a rational number or a natural number, but it could give us a rational number when we take the square root of it. Okay, if not, the decimal will not solve nicely. Okay, it will not solve to be a rational number. It'll solve to be an irrational number when we take the square root. Now, if the decimal ends in the hundredths, the square root will end in the tenths. Okay, so that's 1 decimal place. Okay, and so this is something that we'll think about, and I'll show you some examples on it in just a little bit. And if the decimal ends in 10,000, so that's 4 decimal places, the square root will end in the hundredths. Okay, or 2 decimal places. Okay, so we're always going to divide the number of decimal places by 2. So if it has 2 decimal places, it will end up with 1. If it has 4 decimal places, it'll end up with 2. If it has 6 decimal places, it would end up with 3. Okay, so that's just something to think about. We won't get into 6 decimal places. We'll just deal with 2 and 4 for the sake of this here. So when we are doing a square root, so something like the square root of 0.25, we notice that the 25 that we have there is a perfect square, so we can use that. It ends in the second decimal place, so we can use that as well. Now, the answer, square root of 25, is 5. Now, what we're going to do is we know that this has 2 decimal places, so our answer will have 1, so we will make this answer have 1 decimal place, and the answer is 0.5. Okay, so in fact, if we do 0.5 squared, we're going to get an answer of 0.25. Now, a couple more examples here. You'll notice that we have 0.04. Well, we have the number 4, okay, that's the only number that we have there. That's a perfect square, right? The square root of 4 is 2, okay? And it's in the hundredths, so it has 2 decimal places. So our answer is going to have 1 decimal place, and it's going to be the square root of 4, so it's going to be 0.2. Now you'll notice, this isn't a natural number, so this isn't a perfect square, but we can solve it using our perfect squares that we have. And in fact, the square root of 4 is 2, and so that represents our answer there. 256. Now again, this is a little bit of a bigger one, okay? Meaning that, well, we kind of need to know some of our bigger perfect squares. And so first thing we need to do is 256 a perfect square? Okay? Well, if you look at your values, you'll recognize that 256, the square root of that is 16. Okay? So the square root is 16. Now, next thing we look at, how many decimal places does it have? Well, it has 4 decimal places, so we know that our answer has to have 2 decimal places, meaning that we're going to have 0.16, 2 decimal places, is the square root of 0.0256. Now, if you don't trust me on that, again, it's a little bit tough to do the calculations. I'm just going to use a calculator in this case. If we do 0.16 squared, we get an answer of 0.0256 as the answer. Going backwards, the square root of that number is 0.16. 3.91. Okay, then we have to go and figure out, is this a square root? Well, we look at 3.91. It's not a perfect square. Okay, so it's not a perfect square, meaning that it in fact is something very different. Okay, so this one is not a perfect square, and we're not going to worry about solving it. Okay. On the other hand, and I just want to show you an example that's very similar to this one, 3.61. Okay, I just tweaked around a little number here, right? The 6 and the 9, just change those. But now we know that the square root of 361 is in fact 19. Okay, now you'll notice here we have 2 decimal places, so our answer has to have 1 decimal place, and so it's going to be 1.9. Okay, and that's going to be how we solve if we have a number bigger than 1. Okay, so we don't have just a 0 there. Then we need to do that. Okay. So that's taking square root, and you'll have a bunch of questions on that. We can think of it as the opposite of squaring a number. If we square something like 0.2, there's 0.2 square root, right? What we need to do is we take this value squared. So 2 squared is 4, or 2 times 2 is 4. Now, the answer is going to have twice as many decimal places as the original. This one has 1 decimal place, so our answer has to have 2 decimal places. Now, their example right here, 0.03 squared. 3 squared, I'm just going to put this over here, is 9. This has 2 decimal places, so our answer is going to have 4 decimal places, and so the answer would be 0.0009. Okay. Final example here is 0.012 squared. Now, I did say I wasn't going to go too big, but this one will be one of our examples here. 12 squared is 144. We have 3 decimal places here, meaning that our answer will have 6 decimal places. So it'll be 0.000144, 6 decimal places with a 144 at the end. And this gives us our, if we're squaring certain numbers, okay, squaring decimals. Again, if we have nice decimals here and we're squaring them, we can come up with nice values based on our perfect squares that we know. Now, I want you to work on questions 1 through 4. I realize this was a long lesson and it was all kind of together, but all the questions are kind of all encompassed together as well. So I want you to work on questions 1 through 4. They deal with taking the square root of decimals and understanding, is it a perfect square or is it not a perfect square, such as this one right here. Okay, so take a look through, go through those and answer those questions.